Imagine two identical clocks, but one that is working, A, and one that is broken, B. Although both clocks are exactly the same, one of them has more mass than the other. But which one? The answer? Clock A, only because it has extra mass. Now, what exactly is extra mass? Extra mass is any form of mass that is added onto the total mass of a system. In short, clock A has just been eating the kinetic energy of the moving hands, elastic potential energy from the winding spring, and thermal energy from the friction of the gears. And since energy has mass, the clock gains mass. Because it's not like your parents are already adding mass on you. Next question. What about the mass of the clock?
Well, with a little bit of algebra, E equals mc squared becomes m equals E over c squared. And since the amount of energy is small and the speed of light is constant, by dividing the energy and the speed of light squared, the amount of extra mass, m, gets smaller, which is added onto the current mass of clock A.
So, to sum it up, energy has mass, which then makes up the extra mass, and the extra mass makes up part of clock A's total mass, causing clock A to have a greater mass than clock B.
So now it gets a little weirder because we're scaling down into the quantum universe. What's different about the mass of an atom compared to the clock's mass?
Easy. As the electron nucleus, which is made up of the proton and neutron, start to get close to each other, they actually start to subtract the total mass of the atom. And since they are so small, energy makes up their entire mass. Now the reason they start to subtract the total mass of the atom is because the electron, one particle, creates a small quanta of positive kinetic energy in its orbit around the nucleus, the same energy as an overachiever. Whereas the electron and nucleus together, three particles, create a greater amount of negative potential energy, the energy of a couch potato. All three particles create negative energy, whereas only one of them also creates positive energy. So in short, the fact that 3 is greater than 1 is the reason. Last but not least, the total mass of an object also depends on its energy content. So, the question is, what if you add a momentum to the equation? Well, it would become...
So let's say you were to be moving inside a box and weighted precisely relative to a box in which you stood. You would find that the box in which you moved has more mass due to the thermal energy inside.
What E equals mc squared means is that an object with energy has more mass relative to an object with no energy content at all. This is key to understanding special relativity, and this is the real meaning of E equals mc squared.